Today we will discuss about the multivibrator. Multivibrators, we are discussing the electronic devices in circuits. That's module is 3. Topic name is a multivibrator. Multivibrator are square wave generator, produce a pulse waveform with various on time and off time. Age figure 2.3 shown in figure. This is the figure 2.3. P1 and P2 is on. This is the on. This is the P2 P2 P, and this is the P1. This is the on, and this is the on, and this stage is off, and this stage is off. So do on time of the whose total time period is. So this is so multivibrator. They produce the output like some slope maybe this like this. So this they produce the output like they can look like this or look like this or look otherwise they can add some slope maybe slightly slopes also they can produce the output like this. The state transition may have slow small time transition for small time. The state of transition may have a small with a small time for transition or finite number of slope. There are a three type of multivibrator available according to their station. They are the first astable, monostable, and last is bistable. First, we will discuss about the astable multivibrator. Astable multivibrator is one that generates the pulse whose transit from one state to another state without external triggering. In astable multivibrator, there is no need to external triggering. It is done by its free. It is done by its free will control the designing. There is no need to external. That's this is called that's why this is called a free running oscillator because it has two quasi states. So it always one stage to another state and another stage to next stage is moving like this. This is the that's this move like this. This is the multi-stage move. So this is the moving like this. This is the both stage are quasi states. So that the state are not there is no state is stable, only this is no stable stage for long time. It state can be terms as a quasi state because there is quasi state means unstable state, hence the multivibrated generate the pulse with no stable state is called a times terms as astable. That's why name is terms of astable. The monostable multivibrator. Monostable multivibrator, it has one that generate the pulses those transit from the one state to another stage helps to by the external because its one stage is stable. So that's why if that multivibrator is on stable states that we need to put the external triggering so that it can go on quasi states. That's why we need to put there's a one stable state. Next is monostate. This present one when external pulse is applied on its transit from present state that is stable state to quasi state. External quasi state it remain at the quasi state for a time of period t is designed, then it return to it must be quasi state only a design period for t duration, then it return to stable state without any external triggering. For becoming without any external triggering means if it once goes to quasi state, for it will stay a designed time t in that quasi state. After that it will again come to the stable state. Since state to it changes from a state from stable to quasi state using external triggering, so it terms as one shot multivibrator. Its name terms as a one shot multivibrator or mono stable multivibrator. Next we will discuss the bistable multivibrator. Bistable multivibrators is one that generate the pulse those transit from one state to another state with the help of two external, because here both states are stable. If this it had both states are stable, it if the multivibrator goes to one stage, because so it stay that stage for long term until we are not applying any external triggering. So here two external triggering is required because both state are stables. For one stage to another state, triggering is required. This multiplier head has a stable state. This has a stable state. The stable state only in transition happens when trigger is are applied. Without triggering, no transition will happen. It terms as a bistable. That's why though both are bistable means both state are stable. On the other hand, how to calculate the duty cycle? Duty cycle is nothing but on time. This is the on time divided by a total time. On time divided by time. Total time is nothing but t on divided by a t off plus t on. In this way, duty cycles we can here if the t on is 5 millisecond, t off is 10 millisecond. The question they can ask the one problem like this: if t on, find the duty cycle. Suppose that t on is a 5 millisecond. Duty cycle t on divided by t on plus t off. T on 5 millisecond what is t off, t then t on again 5 millisecond plus t off what is t of 10 millisecond. So total is 15 millisecond. 5 by a 15, so 5 3 ja 15, so this was 1 by 3. This is the duty cycle. In percentage, we can write 33.33, 33.33 percentage. In this we calculate a stable multivibrator. This is the diagram of a stable multivibrator. Terms as a free running multivibrator. We have already discussed it free running because its both states are unstable. They have only one quasi stable states seen earlier conduction. The circuit diagram of a stable multivibrator using operational amplifiers shown below. This is the circuit of a stable multi using operational amplifier. This is the circuit diagram of a stable multivibrator. This is the capacitance is connected here. In feedback, negative terminal, feedback resistance is connected here like this. This R1 and R2 are that the beta into this is appeared directly across it. This is the diagram of, because there is no analysis in our syllabus, that's why we cannot analyze the circuits, because no analysis in our syllabus. Then we will see this is the output initially. This is the output diagram. Initially capacitor initially is output is minus b states. Then this no analysis it not needed to because this no in. Then we will have to discuss the monostable multivibrator. Monostable multivibrator. These multivibrator term is a one shoot multivibrator. One shoot multivibrator. They have only one stable state, and other is a quasi stable state induced by a one triggering. So it can be seen in electrical conduction. The circuit diagram shown. This is the circuit diagram construction. This is the triggering circuit. One capacitor is connected here. Cross diode is connected. That this diode limit to capacitor charge up to limit to charge more than 0.7 milliwatt. If the this diode charge so capacitor charge is more than 0.7%, this diode become on. That's this circuit becomes short circuit. Triggering is like this circuits on op-amp like triggering. The one end capacitor and resistor are connected. At one end, this capacitor and resistors are connected. This is the capacitor. This talking about this capacitor and resistor are connected here. Connected to the inverting terminal. And other end the resistors are connected to the output terminals, and other two and this resistor 1 and resistor 2 are connected are the construction of connect, are connected to the output terminals. That's of capacitor connected to ground. A diode D1 is connected to parallel to the capacitor C. Diode D1 is connected to parallel the capacitor C. This capacitor C, this capacitor C and and feedback resistor are decided the time period of C. The time period this R this similarly this R and C decide the time period. How that's used for deciding the time period. The capacitor C and feedback resistor decide the time period of for multivibrator. A resistor R1 is connected between the output terminal and non-inverted terminal. This is the output terminal. This is the R1 is connected output. This is the output terminal, and this is the non-inverting terminal. Non-inverting this is connected between the R2 and non-inverting terminals. Non and ground terminals. If the output voltage is considered as a V0, then voltage tapped between the R2 will be reference voltage. For according to this voltage and here the same voltage for this, so this voltage alpha into this up to here voltage that reference junction for the comparators for check level check of the comparators. Next is stable because in our slave there is no analysis, we can not analyze the circuit. And next is a bistable. So this is the about the monostable multivibrator.